Alright, welcome to the statistics final. Feel free to print this out and fast forward and rewind. There's going to be a lot of definitions and a lot of stuff. I'm going to go through it quickly, so you may have to rewind some of it or go back in and look at your videos. Alright, number one, define statistics. It's kind of twofold. It's first the design of a study, and second, analyzing the data from the study to gain understanding. Right? So it's first the design of studies, the design of a study, and second, analyzing the data that the study produced to gain understanding. Right? Okay. Number two, list and describe the three main phases of the statistical process. I'll give you these three. You have to go back in and look and get your definition. But it's design, right? You design the your study. Description, right? That's kind of your analysis, and then any inferences that you make, right? So that's your three: design, description, inference. You may want to go back in and be a little more clear though on your definitions of what those are. Number three, define probability. Probability is a framework for identifying how likely a certain outcome is, right? So it's a framework for identifying how likely a certain outcome is. Number four, the entity studied is called the subject. Number five, the population is the set of all subjects in that particular area of interest. So you could say the population is the set of all subjects in a particular area of interest. Right? So number six, define sample. Right? The sample is the members of the population that are being studied. The members of the population being studied. Number seven, in your own words, why would it be important to randomly select a sample? So I'm going to leave that one up to you. Go back in and think about that. Why would it be important to randomly select your sample? I did give you that in one of the videos. Number eight, when sampling, it is the size of the sample that is important, not its relation in size to the overall population. Right? So basically, what that means is 1,000 sample size of a 10 million person country is about as accurate as 1,000 sample size from a billion person country, right? So it is the size of the sample that is important, not its relation in size to the overall population, right? Number 9, define descriptive statistics. Descriptive statistics are basically ways of summarizing collected data. Ways of summarizing collected data. Right. Okay. List 3 types of descriptive statistics. A chart, a graph, an average. Those are 3 good ones. There's others, but those are the 3 most common. Number 11, define and give an example of inferential statistics. I'll give you the definition. You're going to come up with the example. So the definition of inferential statistics is a method of making a decision or prediction about a population by only looking at a sample. Right? So you're making a prediction about the data that you're looking at. So descriptive statistics just describe what you're looking at. Inferential statistics try and make a prediction or an assumption of something based on the data, right? So they're looking forward to a prediction, whereas descriptive statistics just tell you what's there. Inferential statistics try and infer something about the future by looking at the statistics. So come up with a good example for that. Number 12, define parameter. A parameter is the value for the entire population, right? So it's the kind of extreme values, if you will. So probably the easiest way to say that is the parameter is the values for the entire population. as opposed to a sample is just, something chosen out of the parameter. The parameter is the whole potential population there, right? Okay, so parameter is the values for the entire population being studied, the entire population being studied, right? Okay. All right. Number 13, give an example of the most common type of data file. That's a spreadsheet. Number 14, what is a variable? A variable is the thing that you're studying, right? So any characteristic that you want to study is your variable. So if I'm trying to study how tall somebody is, right? We use that example quite a bit in the school. That's my variable, is the heights of everyone, because that's what I'm studying. And so some of my answers are going to be 5 foot, some of them are going to be 6 foot, some of them are going to be 7 foot. The answers are variable because that's what I'm studying, right? Okay. Number 15, list and define the two most common types of variables. So this is the categories that we're looking at, is numerical or categorical, right? So the numerical ones are, your numbers, anything that has a numerical value to it. Categorical are things that are not numerical. So maybe if you did a survey where people were answering yes or no, that's categorical. You can't put a number to that. Or if you ask people what their ethnicity is, are you Caucasian, are you Hispanic, whatever it is, those aren't going to be numbers, right? So those are categorical variables. If you ask somebody how tall they are, they're going to give you a number, right? So that's a numerical variable. All right, number 16, data values derived from a variable are called observations. Number 17, what are the two most important features to describe in a quantitative variable? Now this, depending on your study, maybe there could be something different, but traditionally these are the two more important things, are the variableness and the center. Variableness and the center, right? Number 18, define a Pareto chart. Pareto chart is a bar chart that's arranged from largest to smallest. A bar chart arranged from largest to smallest. Number 19, what is the difference between a histogram and a bar chart? Well, a histogram is basically like a bar chart, but it's for quantitative variables. So the bar chart would be more for your categorical variables, right? And if you make a bar chart for quantitative variables where it's just numbers, it's actually called a histogram, right? Okay. Number 20, explain in your own words why observing the shape of a distribution can be valuable. I'm going to leave that one up to you. We've talked quite a bit about the shapes of the distribution, so give me some thoughts about what you could learn from observing the shape of a distribution. Number 21, list and define the 3 M's, right? So I will give them to you, and then you can come up with their definitions. The 3 M's are mean, median, and mode. Mean, median, and mode. Number 22, list and define the 2 types of distributions. Alright, so the 2 types of distributions that we're talking about for this, let me pull this up here. Trying to think if I was giving you, not bimodal and modal, let's not do that. For this one, what I'm looking for is symmetric and skewed. Okay. I was trying to think, because I also gave you modal and bimodal, but that's not what I want for this question. What I want for this one is symmetric or skewed, right? So the 2 basic ways of understanding a distribution is either going to be symmetric, like the bell-shaped curve, or it's going to be skewed, meaning that the majority of the answers are to one side or the other, right? And so those are your 2. So symmetrical means that either side that from the mean in the middle, either side is the same. That's symmetrical, right? And then skewed is when there are more observations on one side of the mean than the other, right? Okay, or the median than the other. Okay. All right. And so the skewed distribution, instead of it looking like a nice hump in the middle with the bell-shaped curve, the hump is either to the far right or to the left, and then the side that doesn't have the hump has a really long small tail. And so those are called skewed distributions. So a skewed distribution might be income, right? Whereas the majority of the people may be to the left side of the chart at 100,000 a year and under. There's a whole bunch of people, at least a few, that are billionaires and multimillionaires, and so their observations, their part of the chart is going to be way off to the side, right? And so that's a skewed distribution. All right. Number 23, data collected over time is called a time series and is displayed using a time plot. Time plot. Number 24, what does this E-shaped symbol mean? That's sum, right? That means sum, to add up, to sum everything together. Number 25, what does the variable n normally represent? That means the number of observations. Number of observations. Number 26, what does the variable s normally represent? It normally represents the standard deviation number. Okay. Number 27, define an outlier. An outlier is any observation that is to the extreme on one side or the other from the average, right? So it's any observation that is to the extreme on one side or the other from the average. Number 28, define range. Range is the difference between the lowest and the highest observations, right? So whatever is to one extreme and then the other extreme, and you subtract those, that's your range, right? So it's the difference between the largest and smallest observations. Okay. Number 29, define deviation. Deviation is the difference between the observation and the mean, right? So the mean is your average there, and the observation is whatever point you're looking at, whatever person's survey that you happen to be studying, and the deviation is how far they are from the average, right? Okay. Number 30, in your own words, explain what it means if something is in the 65th percentile. Okay, I'm going to leave that one up to you. Number 31, what are the three quartile values? So remember, we think of like a quarter, 25, 50, and 75. What is interquartile range? That's the third quartile subtracted by the first quartile, right? So the 75th quartile minus the the 75th percentile minus the 25th percentile. So the third quartile is that 75% number. The first quartile is the 25% number. The interquartile range is when you subtract that. So you subtract the third one, the first one from the third one, right? So you've got the third range there, which is 75, and you subtract the 25 from that, and what that leaves you is all the numbers in between the 25 and the 75, and that's your interquartile range. Is all of the observations between the 25th percentile and the 75th percentile is the interquartile range. All right. Number 33, define z-score. Z-score is the standard deviation score, or the standard deviation number, however you want to say that, from the mean. So whatever something z-score is how many standard deviations it is from the mean. So if it's 1.5 is its z-score, that means it's 1.5 standard deviations from the mean. So the z-score is the number of standard deviations that an observation is from the mean. Okay. Now I know we did that quick and there's a lot of things in there, so feel free to fast forward, rewind, go back, look at your videos, whatever you need to do, okay?